Thank you very much, Merle. Greetings, everyone. Thanks to Merle and her team for organizing this event. I really enjoyed the session yesterday, and I'm looking forward to hearing the talks that follow mine. As Merle mentioned, I'll be presenting some work on underlying causes of individual differences in rhythmic interpersonal coordination. Of course, those of you who were here yesterday are intimately aware of what is entailed in rhythmic interpersonal coordination, what is special about it in humans in terms of its precision and yet the flexibility with which it can be carried out, and the broad range of contexts in which it occurs. And for me, one of the areas of interest is in the musical domain. Ensemble performers coordinating with one another, and why we do it, and even more specifically, how we do it. And one guiding principle, and one of the reasons why I think it's a remarkable topic and one worthy of a lot of attention, is that music can be viewed as a microcosm of social interaction. And what we mean by this is that participating in collective musical activities draws on a range of processes going from basic sensory through perceptual, cognitive, motor, and emotional that support other forms of social behavior in our everyday lives. And in fact, one of our presenters yesterday, Alessandro, and some colleagues, we penned a paper arguing for some of the benefits of using music as a platform for studying human social interaction because of the fact that due to its cultural conventions and systematicity, it can be used to parametrically model the complexity of a broad spectrum of behaviors, going from an individual interacting with a recording right through to live performers interacting with one another and an audience. What I think is another noteworthy thing about rhythmic interpersonal coordination is, despite its fundamental application in different fields of endeavor, different activities, we find that it's characterized, like any human capacity, with variations. These occur between individuals. So if one does a basic sensory motor synchronization task, such as finger tapping with an auditory pacing sequence, one finds that individuals within the population vary in their ability to tap in synchrony with the sounds. And furthermore, a different type of variation, when you look at real ensemble coordination going on in different musical styles and across different cultures, you find different preferences, one would say, if we're talking about experts who are intentionally modulating their behavior to create different degrees of asynchrony that might fluctuate over time. You can find signatures of this that distinguish different styles of music. So that's another form of variation. And the question is, what are the underlying causes of these variations? What are the factors that contribute to them? My own interest has been pursued using a theoretical framework that tries to get at the psychology of musical ensemble performance. And it's got multiple levels. One level reside what I refer to as ensemble skills. These are real-time, online, sensory, motor, and cognitive processes that determine the quality of coordination, processes that allow one performer to anticipate another performer's timing, to adapt to fluctuations in their timing, and to attend to co-performers. And at another level, knowledge can affect the operation of these ensemble skills. How well you know the performer's playing style, how well you know the content of the part that they're playing. Goals and strategies are relevant to the extent, for example, that leader-follower roles are adopted and agreed upon. And finally, all of this is embedded in a social context, so factors such as personality might play a role. What I'm going to do today is present some research looking most specifically at the relationship between the two ensemble skills of adaptation and anticipation. And by adaptation, what we are referring to is simply the process of reacting to interpersonal errors via correction mechanisms. And Alan Wing mentioned some of this yesterday in his opening presentation, and Mark Elliott as well. So with colleague Bruno Repp, maybe familiar to some of you, I was privileged to do some work on temporal adaptation, and two processes in particular, phase correction and period correction. So the assumption is there's an internal timekeeping type mechanism instantiated in in the central nervous system, and this facilitates entrainment with an external sequence, such as a tone sequence, via these mechanisms. Phase correction is assumed, and there's some evidence from experiments, to be an automatic process. It's the same sort of process, one could argue, that mediates interaction between other critters like fireflies and so on. Whereas period correction is an effortful process, and it's implemented in the context of sensory motor synchronization when there's a noticeable change in tempo. Okay, so these are two different processes, one perhaps higher level than the other. Anticipation, on the other hand, simply refers to predicting what, when, and how for others' actions. And for the framework I'm discussing today, we're mainly interested in temporal predictions, predictions of timing. And we study this again using sensory motor synchronization tasks where a computer-controlled sequence, like a metronome that varies in tempo, like expressively performed music varies in its tempo, getting faster and slower across a trial. And the task for the participant is to tap along with this. And we can estimate the degree to which people are anticipating versus tracking or following by doing cross-correlation analyses, and I'll come to that sort of approach a bit later. And we're interested in how that ability to anticipate is related to what's going on when two people are really interacting with one another. And former PhD student Nadim Pachenko studied this with dyadic tapping tasks, finding that if we estimate how much individuals are predicting or tracking tempo changes in a simple task with a computer, we can use this information to make predictions about how well they interact with another human based on whether they are both high in terms of predicting, whether they're both more inclined to track tempo changes, or mixed pairs. And we find that the predictors have lower dyadic asynchrony. They're better at synchronizing with one another than the trackers, and mixed in between. So there's some evidence for individual variations based on anticipation. To understand how ensemble scores of adaptation and anticipation work together, we've developed a computational model with initially PhD student Marika van der Steen and a whole host of colleagues, and you can note our fearless chair amongst them, so the model is referred to as ADAM, standing for Adaptation and Anticipation Model, and it has several modules, and hopefully you can see my mouse. In red, we have an adaptation module, so that's instantiating the processes I just discussed before of phase and period correction, designated with an alpha and beta. And then an anticipation module that has a extrapolation process. It extrapolates into onset intervals to predict what the next one will be, okay, anticipating a tempo change, and perseveration, just copying the previous interval. And this can be used to modulate the degree to which, or to estimate the degree to which somebody is predicting and tracking. And the assumption is that these work together. The adaptation module takes asynchronies between own sounds and other sounds and implements phase and period correction on the basis of that to inform an internal model of the self that determines the timing of one's next action in a sensory motor synchronization task. The anticipation module, on the other hand, takes information from the other sounds, and based on this, generates a prediction about when the next sound will occur. It gives this the other internal model. And then these can be compared, and this is where anticipation and adaptation are linked. And this is before the next action is carried out. A comparison takes place between when the self is planning his or her next action and when that individual anticipates the other individual will perform an action. And if there is a discrepancy above a threshold, a joint internal model can implement anticipatory correction and update one's own action plan before a motor command is issued. Okay, and this is a linear autoregressive type framework, and there are the equations and showing each of the different parameters that reside in each module. So we've used this in several ways, and one important thing to establish is that whether this sort of model provides a good account of human behavior, and we've done that. That's the 2015 paper there. And then we've also, really with Nori Jacobi here, developed methods for estimating model parameters analytically, okay, which is useful because it can be done in real time as well, although that's not what I'll be talking about today. Okay, so when one uses this model, you can find, okay, again, we can break down the variation in individual synchronization skill and see how different processes are contributing to that. And we find that it's actually very systematic, and these three processes of adaptation with the two inherent processes of phase correction and period correction pooled here, anticipation and joint performance, predict asynchrony, okay, quite nicely. So individual differences in ensemble skills, as reflected in atom parameters, predict coordination success. What I want to talk about today, as I mentioned, it's the title of the talk, the sources of such variation in anticipation and adaptation and how those affect behavioral synchronization skills. And one can look at this question of sources at different levels. One can look at brain structure and brain functional processes. This is one area that we're working on. And another area, however, gets at the social core of the issue and looks at links between the processes of anticipation, adaptation, and personality factors. So, and the chief ones that we've been looking at, and which I'll present some new data on today, are empathy and locus of control. Okay, so again, I guess Merle makes many appearances throughout this conference, and here is another one because it's in fact Merle who initiated this line on the relationship between locus of control and adaptation. This was in fact an fMRI study done, but I'm just going to present behavioral results now. This work was done using a nifty trick. It's a method originally developed by Dirk Forberg, and it involves synchronizing, the task involves synchronizing with a computer-controlled virtual partner. Why it's nifty is because the virtual partner is programmed to instantiate, in this case, period correction, so one of the adaptive timing processes. It operates like another human would if that human were being adaptable, and if they're doing it with moderation, cooperative. And however, of course, there's a trick. We know, and I was discussing this with Merle before, she used to do pain research. So of course, the experiments can be a bit trying for participants. And in this case, that was the case because the virtual partner in some conditions was programmed to employ a high degree of period correction, which actually meant that they were unstable, the virtual partner. It was prone to drift. It could get faster and faster and faster, or slower and slower. And the whole thing could fall apart in terms of coordination. So participants were instructed with a twofold instruction to synchronize with the virtual partner, but also to maintain a steady tempo, okay? Because the virtual partner in some conditions would lead the individual astray. And what was of interest was how those instructions were prioritized based on locus of control. So it's an aspect of personality that is related to whether one attributes life events to external or internal causes. So if I fail an exam, if I'm external, I could say it's because the professor was a poor teacher, but if I'm internal, I say that I failed because I am stupid or lazy or whatever. Anyway, so you think, okay, what's this got to do with synchronization? Well, in fact, it does relate to the way the human participants react to the unstable virtual partners. So individuals who are internal locus of control tend to focus when the partner isn't reliable on their own actions, okay, stabilizing their own performance, and not so much on synchronizing. So they're maintaining tempo rather than synchronizing, whereas external do the opposite. And when one estimates phase correction, one finds, or human adaptation, that the internal locus of control people are acting like leaders in the sense that they're not adapting much to the virtual partner. Okay, let's switch to anticipation now. And in this case, we, with former PhD student, postdoc, and honors student, and now Giacomo is his own man, so to speak, working in Rome. And we were interested in another aspect of personality, empathy, and even more specifically, perspective taking, the ability or the tendency to put yourself in somebody else's shoes. So it's kind of a cognitive aspect of empathy. And what we had people do was play a tune together. And actually in this study, they were non-musicians. So they weren't playing musical instruments. They were playing e-music boxes, Giacomo calls them. They're like the little music boxes where you turn a lever and play a tune. You just have to regulate the tempo. The notes come out in a fixed order. So anybody can do it and play a tune. Prior to doing this and prior to bringing them to the lab, we assessed empathy, specifically perspective taking, we were interested in, and paired people up into high and low empathy pairs and found that the high empathy pairs had lower asynchronies in their performance. What was even more interesting, however, in this particular study, we had a condition where we designated one person as a leader and the other as a follower. And there we found that the designated leader, it didn't make a difference whether they were high or low empathy. They could do the job well and they tended to produce a more steady tempo. However, the follower did their job well depending on whether they were high or low, and the high empathy or high perspective taking followers were better at predicting the leader's timing. Okay, and we know leader-follower relationships are important in different contexts. In this case, it's a matter of mutual influence, who adapts to whom and by how much. And we saw some nice data from Alan Wing yesterday with a couple of string quartets. I think one was the German one, the more autocratic situation where the first violin wasn't adapting much to co-performers and the others were, and the other where it was more egalitarian or democratic. So that's an example of different types of leader-follower relationships. And we know that there's some quite elegant and simple ways of estimating what's going on in terms of mutual influence that can be applied simply in the finger tapping or drumming task. So Ivana Konvalinka has a study a while ago on this using cross-correlation analyses, finding that, for example, if you have paired individuals, but they can only hear themselves, like each individual only hears their own actions there, when you look at lagged cross-correlations, so lag 0 and lag +1 and -1, the cross-correlations are near 0 all the time. They make sense, they're not interacting. However, when they can hear the other person, then you see this particular distinctive pattern where lag 0 cross-correlations are negative and lag + and -1 are positive. So in other words, it indicates one participant's intertap interval is similar to the partner's previous intertap interval. So it's a measure of mutual influence if it goes both ways. Another point I wanted to make about leadership is that it has costs. So in these sorts of tasks, leader assignment can actually increase asynchrony. And this happens if you have a free improvised task. Leon Noy showed this, and we've shown it in the music box task as well, which is a highly constrained task. And this raises some questions, which we'll see in new data. Okay, so what I want to present today is a new study. It's not yet published, actually, linking performance, model parameters, and personality. So we're interested in adaptation, anticipation, dyadic tapping with prescribed tempo changes. What we want to do is explain variations in interpersonal synchrony and mutual influence by estimating atom parameters and look at the effects of leadership assignment on these processes. And of course, the underlying question is how personality modulates the atom parameters to affect behavior under different leadership conditions. So the basic task is one where we have dyadic synchronization, and it's a drumming task. People prefer this to finger tapping. Trial starts with a metronome that gives the tempo. The participants tap along, then the metronome stops and they continue for 50 taps, and they're each producing distinctive conga sounds by their drumming taps, as I'm calling them for convenience. What we are varying, two things, the tempo profile, so whether it's regular or variable, whether it's slow or fast, I'll collapse across that for now, and whether there's a leader assignment. And we're going to be mainly interested in the variable tempo case, because that's where leadership can be expected to play a role. We assess empathy using the interpersonal reactivity index and locus of control, as before, using the internality, powerful others, and chance scales. And we're interested in the internality subscale, which we used with Merle previously. Okay, so here are some results. We have 80 participants forming 40 pairs. As in the previous studies, we find that, well, firstly, that tapping with a variable tempo together is more difficult and results in larger mean asynchronies. But more interestingly, when there is a leadership assignment, the asynchrony is larger as well, so that's consistent with previous work. And when we look at the measures of mutual influence, the cross-correlation measures, we see that this effect seems to be due indeed to asymmetries, where participant 1 is influencing participant 2 more when they're a leader, and the reverse when participant 2 is the leader. Okay, but we're more interested now in what's going on underneath it with the atom parameters. So here we have 3 plots showing period correction estimates, no phase correction here, just period correction. The prediction tracking coefficient, values above 0.5 indicate more prediction and below 0.5 more tracking, and anticipatory error correction. You can think of this as paying attention to self and other and integrating them, and high values closer to 1 mean more integration of self and other. Okay, so what we can see here, I have notes on that in the next slide, is that if we look at period correction, this is just for the tempo changing trials. When there's no leader, there's a small amount of period correction going on as tempo is changing. But then when you divide people up by the leader and the follower, the leader is not employing any numerical period correction, whereas the follower is adapting. So reactive period correction is suppressed in leaders and boosted in followers. Nothing going on with prediction and tracking coefficient. It seems to be more of a tracking task. It is a challenging task. And there seems to be almost a ceiling effect with integrating self and other, which is actually a positive thing. However, when you dig down and look at individual differences, so relationships between parameters and performance, we do a hierarchical regression. So we enter average scores for the pair for each parameter and also differences between pair members into a regression models in stepwise order. So first just period correction, the most basic, adaptation, then anticipation, and finally anticipatory error correction. And what we find is that there's a negative relationship. So higher period correction means lower asynchrony, which is good. And then you find that a difference between prediction and tracking also makes a difference. And here, the bigger the difference, the bigger their synchrony. So it seems that people entering into a leader-follower relationship, not one that's instructed, in fact, but they're doing this, and it's detrimental, as we know from previous work. Okay, how is this correlated with personality? This is the main result. So if you look at internal locus of control, we see that it is positively correlated with period correction. So we know from the study I mentioned with Merle earlier that internal locus of control focus on stabilizing their own performance and reducing phase correction. They're actually increasing period correction. So internal locus of control seems to be associated with the ability to control one's internal timekeeper. And when it's beneficial to be stable, the control allows period to be constant. But when it's beneficial to change tempo, as in this task, this control allows period correction to be adjusted flexibly. And when we look at anticipation, we generally find that, as expected, perspective taking is positively correlated with the prediction measure. Okay, so we have kind of a dissociation between the parameters and personality correlates. Okay, just the last slide. We found that personality correlates with anticipation and adaptation, but what about the joint module? And in related work, we've looked at even a higher level aspect than personality, social beliefs. So social biases about how cooperative a partner is can influence the weighting of information of self and other. So Peter Mills carried out this study where participants were brought together into the lab in separate booths, and they were told that they were synchronizing with the other individual or a computer, but in reality, it was always the virtual partner so that we can control things. And what we found was that people actually had preferences. Some people said that they preferred and thought they did better when they were interacting with a human, and others thought they did better with a computer. And when we look at the parameter estimates from Adam, that pattern is reflected in the joint module. Okay, so that seems to be where your social biases for expecting the partner to be more or less cooperative plays a role. So it's a high level expectation, social expectation. So to conclude, adaptation, anticipation, ensemble skills work together, facilitating rhythmic interpersonal coordination. Leadership assignment affects coordination by creating asymmetries in adaptation mainly. Individual differences due to dissociable links between ensemble skills and personality were found. And links between basic sensory motor mechanisms and social cognitive processes are probably regulating the balance between the integration and segregation of psychological representations of self and other. That's the end.
That was very anticlimactic, Peter. You need to have a big finish. You know this.
I was going to say the same thing because normally there would be thunderous applause. I'm accustomed to standing ovations.
Well,
I'm assuming that's what's going on.
I'll sing for you. I'll sing for you.
No, okay.
Wonderful. Thank
Yeah,
you
if
so
anything
much.
wasn't clear, so any questions of clarification or more tricky ones, please
As
let me
ever,
know.
you were exceptionally clear, and I hope you don't mind. I've taken about 1 million screenshots because there was so much in there that I want to think about. Obviously, some of the stuff I knew. What I didn't know about was obviously Giacomo's paper on, so the November 2019 paper on empathy, which ties in nicely with some of the data we got working with autistics with Svenja Körner and Isabel Jobbik in Berlin, obviously. Where we showed, so they actually used the finger tapping task as a proxy for the benefit of their intervention to make people try and perspective take more, to try and learn to adapt, as it were, because they too show this preferential bias for less adaptive partners to begin with. Yeah, so I thought that empathy work is beautiful because it replicates that then in neurotypicals. With a very large N, so that is wonderful. But I sort of want to just see, first of all, if there are questions coming up, because I know there are a couple of people watching who I know specifically know your work and might have some clarification. But for the moment, because of the lag, they're still probably typing. So I'm allowed to jump in. And I was taken by the slide that you went through quite quickly, in fact, on the so-called costs of leadership, which I think is a really interesting idea, because it might indeed be that the cost of that leadership that maybe puts you into either the category that empathizes or not. It's just too costly, or just it doesn't work for you. So I thought if you could maybe pick up on that slide, which, as I said, sadly you had to jump through. Yeah. So what do you think about this idea of a cost of leadership? Because
I think it depends on the task and the number of interactants, the number of people. I think if there, of course, are some situations. I mean, I'm sure need no convincing. And from the discussion yesterday, after Alan's talk, and from the data we saw in Alessandro's talk as well, we know that in some ensemble situations with large groups and different sections within them, where the intrapersonal and intergroup, well, there's intrapersonal as well, and then within a section and between sections, the coordination challenges get to the point where a leader becomes useful. And in fact, the work referenced by Alan briefly in his talk, he talked about the trio analysis by Rudolf Rasch. And in a chapter by Rasch, he actually does a modeling exercise asking the question, how many people do you have to have in a musical ensemble before a conductor becomes beneficial? And what the analysis shows is that he finds a critical number is around 9. And actually, if you have a conductor below 9, the prediction from the model is that it'll actually be detrimental. There's a certain point where it actually makes sense to listen to one another, and it might relate to how the adaptive mechanisms like phase correction work, how they can be distributed. But it gets to a certain point where you have a large number of people, and maybe if you're just attending to close neighbors, things will kind of fall apart in some way, and then having a single referent for the group becomes beneficial. And of course, in larger groups, you have in orchestras, for example, section leaders, and the section leaders are listening to other section leaders, and of course, everyone should be following the conductor. So in large groups, I think leadership is operating differently than in a dyadic situation is one factor. The other factor is that one can define leaderships in different ways. We know from the study where that we did, where we were talking about leadership as kind of a default thing where you're the leader if you're actually just not adapting to anyone. But that's not necessarily a good leader quality in a broader sense. There are different types of leadership. The leader can be defined as in terms of, work with coordination smoothers. So the people who are producing gestures that are supposed to help others to coordinate, the person who makes their timing more regular for the benefit of others. In some situations, leadership then becomes even more organizational, if you like, deciding which pieces to play, how to rehearse them, what tempo to take the work at, whether to slow down or get faster at a certain point. So there are different ways to define leadership. So with this work that we see on the slide, with noise mirror game, the idea was that it's beneficial for this improvised task, which comes from theatre sports, I think, but it's constrained here. If you have one person leading, the person following is jittering around them, and that creates variation, whereas somehow what he calls co-confident motion occurs if you don't designate a leader. And in the e-music box task, I know, having been involved in that study, when you have people turning this thing to play Somewhere Over the Rainbow, as the case was be, these were mainly with non-musicians, and you really do have a situation where one person is almost sitting around waiting for the sound of the other person and then catching up. They're playing catch up rather than trying to anticipate or even guess when the other person will produce a sound. So that's the problem. It's skewing things totally to a reactive strategy, which is the problem when you have a leader-follower relationship. But that might change if you have a larger group where there are other problems that occur.
No, I think that was exactly what I was looking for. And it really sort of situates a lot of the things you were saying as we enter this question of what happens when you scale up in terms of group size. So on that note, I'm going to thank you for your time and for your presentation, Peter. There may be more questions that pop up in the YouTube chat. So perhaps